Welcome to this explainer for the Foundry by Forge College. I'm your host, and today we're stepping out of the planning phase and heading straight into the launch bunker. So grab your stress balls, folks. We're going to take that pre-mainnet checklist we finalized in our last lesson and actually put it to use. We are executing a mainnet launch, but we're doing it with a rigorous aerospace-style controlled rollout. Let's map out our journey real quick. We're moving through our deploying on Solana module, stepping right past general app deployment, and we are now parked securely at executing full deployment. We've built our blueprint, our code is compiled, and you know what? Now we're totally ready to execute our deployment scripts safely and systematically. Here is the launch blueprint for conquering the Solana mainnet today. 1. The mainnet context. 2. Building the runbook. 3. Simulating with dry runs. 4. Canary and smoke checks. And 5, rollbacks and promotions. Let's get into it. All right, Section 1, the mainnet context, transitioning from planning to execution. So, moving to a live blockchain, it has permanent financial consequences, which, let's be honest, can be absolutely terrifying. To put it bluntly, and I love this quote, testing in production without a rollback plan is like jumping out of a plane while still sewing your parachute. Yeah, good luck with that. Instead of those raw, wild, totally panic-inducing mainnet pushes, we rely entirely on staged rollouts. We want to ensure our parachute is perfectly packed and inspected way before we ever leave the plane. Moving right along to Section 2, building the runbook. It's all about executable scripts. Now, our primary tool for this whole mission is our runbook. And this isn't just some vague list of ideas scrawled on a whiteboard. It's an automated bash script that acts like a highly precise machine assembly line. Check it out. Step 1, it builds and tags the version. Step 2, it deploys a Canary release. Step 3, it runs critical smoke checks. And finally, Step 4, it decides whether to promote the release to the public or trigger a rollback. It's just one beautiful unified sequence. But wait, how does the script actually know the rules of engagement? Well, we feed it parameters directly from our pre-mainnet checklist, and we store them cleanly in a simple JSON file. This tells our script exactly what the canary fraction is, the wait time between stages, and the precise latency limits that should trigger an emergency abort mission rollback. Section 3, simulating with dry runs. Think of these as our flight simulations. Before we even think about touching the live mainnet, we need to run validations. You'll notice a pretty stark contrast between our two operational spaces here. On one side, our dry run simulation is perfectly safe. It costs absolutely zero LAN ports. But on the other side, the mainnet environment is live, it costs actual money, and your actions are completely permanent. The whole goal here is to prove the script works perfectly on the safe side before we ever expose our wallets to the live sides. So what does a successful dry run actually look like? First off, the script absolutely must exit with code 0, meaning no errors. Second, a pre-flight summary is printed. Third, it generates a placeholder for the output program ID. And lastly, it does all of this without making a single ping to the mainnet. Rigorously testing your logic without touching the live network, that is exactly how the professionals operate. All right, Section 4, Canary and smoke checks, testing in reality. Once that simulation passes with flying colors, we're ready for the real environment. But hey, we don't send everything at once. Think of a Canary release like a low-risk scout ship. We send it ahead of the main fleet just to ensure the environment is safe. It's a staged deployment where the new program only handles a tiny subset of traffic. That way, if the Canary runs into trouble, the main fleet stays safely in orbit. We mathematically restrict this deployment in our JSON file to a super small fraction, usually something like 0.05 or just 5% of users. And by doing this, we strictly limit our blast radius. Because if there's an unexpected bug on chain, well, 95% of your users will never even notice, and you get to keep your reputation totally intact. A real win-win. Now, right after that Canary lands, we need to know if it actually survived the trip. We do this by running what we call smoke checks. We aren't testing every single crazy edge case here, we're literally just checking for basic survival. Like, can we query an account? Is an expected field returning data? The old saying goes, where there's smoke, there's fire. Well, we just want to make sure our program isn't literally on fire. As these smoke checks run, we're gathering some absolutely critical telemetry. We're looking at the transaction success rate, median confirmation latency, a basic OK or fail status, and system CPU usage. We record all of these results into a baseline JSON snapshot. This gives us the exact empirical data we need to make our next major move.
Which brings us to Section 5, rollbacks and promotions, the ultimate decision.
With our Canary telemetry data safely in hand, we face the ultimate launch decision. Do we abort or do we proceed? You know, the golden rule of robust engineering is that automation must preserve human control. The runbook is great. It handles all the heavy lifting, but it always pauses for a human to review the data and approve the next phase. Ultimately, you remain the flight director. Let's look at the worst-case scenario for a second. If our latency breaches the established limits, the script automatically executes a reversion sequence. Step 1, detect the threshold breach. Step 2, trigger the rollback function. And Step 3, leverage the upgradable loader to redeploy the previous safe binary. It's quick, it's automated, and it is completely painless. But if the telemetry is in the green, we hit the accelerator and promote the Canary. This involves updating our feature flags to route wider traffic to the new program ID. We gradually open up those gates, going from 5% to 20%, then 50%, until the new version is happily serving 100% of the network. Just like any rigorous aerospace team, we finalize the release by securing our infrastructure. We update the artifact registry with a production tag, we revoke or rotate our upgrade authority keys based on our security policies, and we archive those baseline metrics. Remember, the mission isn't truly over until the paperwork is filed. Which brings us to a final provocative thought to leave you with. How will the baseline metrics you just captured shape your long-term monitoring strategy? Establishing these precise baselines prepares you for continuous, automated compliance moving forward. It's a real game changer. Anyway, thank you so much for diving into staged deployments with me today. Be sure to visit forge.college to explore more lessons and elevate your Web3 engineering skills. I'll see you in the next one.